Welcome back. We're in acceleration questions and problems set number 2, the new problem 5. All right, so here we're given a velocity time graph. Well, that's important. Velocity is on the vertical axis there. And we have a yo-yo that's undergoing the hop the fence trick. And we are probably assuming that we don't know what the hop the fence trick is, and that's the hopeful assumption for you as well. And that through this analysis, we'll be able to go and figure out kind of what the hop the fence trick might be or might look like. And then we could always verify that, obviously, with videos online. We're going to make a qualitative position time graph here. So I went and made a position time axis here, and I'm going to line up the times with the times from above there, so then it's like easy to compare. So it's like the 1.0 mark, and it looks like it goes through the half-second mark, so I'll put that down there because that's going to be probably of some importance there. And now I'm going to go through and I'm going to think to myself, hey, approximately what does this look like? Just analyzing it, and then I'll go and make the position time graph. So let's start from the beginning. What's happening at the beginning here? Well, the velocity is negative. Cool. That means that the yo-yo then must be going down. That would be a good assumption there, that down is negative and up is positive. So the yo-yo starts off going down, and then over this first half second here, check it out, it's always going down. The velocity here is continuously negative. However, the velocity is getting smaller and smaller and smaller, approaching zero. So that means it starts off like fast in the negative direction, it starts off fast going down, and just gets slower going down, but still going down. Then it's got a velocity of zero at the half second mark, so it's at least momentarily stationary. And then afterwards, it has a positive velocity, meaning that it's going to be going upwards. Oh, okay, cool. Well, that means that here it's going down, 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 down for the first half second, and then it's going up, 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 up. So maybe this half second mark then is like maybe its lowest point, I'm thinking to myself. Maybe it like comes out of the hand, going straight down, and then slows down when it gets down to like the bottom is maybe what I'm thinking in my head so far. We'll see. Then afterwards, it's going up, 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 and the velocity is going upwards, meaning the velocity is positive, so the velocity is pointing upwards, I should say, and the yo-yo is going upwards. The velocity is getting larger and larger and larger as it goes along here, meaning it's going to be getting faster and faster and faster as it comes back up. Oh, so maybe at the half second mark, the guy flicked his hand, flicked his wrist to pull the yo-yo up, and then started speeding the yo-yo up as it started coming back up there. All right, so yo-yo is going upwards and getting faster up to here, and then something weird happens here. The slope of this graph changes. Well, we remember that the slope on a velocity time graph is just telling us the acceleration. Okay, so it means that from before the 1 second mark to after the 1 second mark, the acceleration changes. Okay, so the acceleration goes from positive to now negative after the 1 second mark. So again, from the half second mark to the 1 second mark, the yo-yo is going upwards and it's getting faster. And then after the 1 second mark, check out what style the velocities are. The velocities are still positive in this first region here, all the way up to 1.1. The velocities are still positive, meaning the yo-yo is still going upwards, but it's getting slower as it's going upwards. Okay, all right. So it's going up, 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 and gets faster, but now it's still going up, up, up. The yo-yo is still going up, up, up. It's just getting a little bit slower until the velocity now reaches zero. So maybe this is like at the top there then, because then afterwards, now check it out, the velocities switch again and the velocities are negative and it's speeding back up. All right, now I have a general sense of what's going on here. Let's see if we can make a qualitative position time graph, so without numbers, and then I'll probably actually go back and put in some numbers because that can be fun too. All right, so let's try and do this. Well, the slope here the velocity is negative at the beginning, meaning the slope is negative on this position time graph at the beginning here. Now, we said that the lowest point is probably around the half second mark, so I'm going to put a low point down there. I don't know where, I'm just going to put a low point. I could start this thing anywhere I want because it doesn't tell us anything about where the zero position is. So if we drew a picture of somebody operating yo-yo, if I can draw that's my yo-yo, and here's the ground here. Chung, 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 chung. Where is the 0 position, you might ask? I don't know. It really depends on how you want to define it. Here's 2 probably logical ways to define it. One, you could say that x naught is 0, the original position, the position at time 0 is 0. And you could say right along that line. Similarly, you might say, no, it makes more sense to have the ground be 0. And you'd be equally correct. And so I'd say those are the 2 logical places to say where the 0 position is. But you get to choose. So if I chose it to start right here, let's say, that would be choosing the first option right here of saying wherever this yo-yo started in the air, however high off the ground it is, we're just going to call that the 0 position there, and then below that would be negative positions. Both would mean the exact same thing. So here it starts off fast and then gets slower, and at this point the velocity is 0, meaning the slope right through that point has to be 0. So I know like right at that point the slope has to be 0. And then the velocity is negative, meaning the slope on this position time graph, it has to be negative at the beginning. So it's got to start off like real negative, and then it somehow has to like level off, you might say, to a slope that is 0. Now check that out. You can actually, if you make that with your hand, it only makes one shape there. Notice I just put in a negative slope at the beginning because I had a negative velocity, and I put the 0 slope there because it had a 0 velocity there. Okay, great. It's that easy. All right. Now let's do the same thing for the 1 second mark there. Well, remember, it was going back up here, so these positions have to go more positive because it's got a positive velocity here. At the half second mark, it's still 0 velocity. At the 1 second mark, it's a very, very big velocity. It's actually just as big as this over here, and it's a positive one here. So that means like right at this point here, it's got to have some positive velocity like that. Now check that out. It has to start horizontal here, has to end, pretty steep over there. There's only one way you can make that shape. So let's go make that shape right in there. Oh, cool. Now you look at that and you go, oh, I got half of a parabola there. And it'd look like a perfect parabola if I was really good at sketching. Maybe it looks like that for you. Then I'm going to put out some other points here. The 1.1 and the 1.2 seem like they're going to be points of interest here. Points of interest. 1.1, and I made that other one there a little bit too far away there. So for my scale here, maybe there and there. 1.1 and 1.2. Now here it's going to get slower and slower and slower. And at the 1.1 second mark, it's going to be going upwards in the first section from 1 to 1.1. So up here somewhere, it's going to have a horizontal slope there, or a slope that is 0 is the proper way to say that. And so now look, it starts at a steep slope like that, it has to end there. There's only one way that you can make that shape really. Oh, and that's supposed to be a parabola. Yeah, well, that's not so good of a parabola. Let's see if I can redo that. So it's going to look something like that. Okay, yours might look a little bit better than mine, hopefully, in this case. And then similarly going down here, it starts off with a 0 slope there, a 0 velocity, and then it ends with a really negative one. So it ends with a really negative one. There's my negative slope there. And so now we have a parabola, a smaller parabola that opens downwards there. Okay, cool. I think you get the idea. All right. Now, if we wanted, we could go back and we could even put in the actual positions there. We could make this a quantitative graph by looking at the area under this position time graph. I look at that triangle that's in there, and I could calculate exactly how big of an area that is, and that area represents the displacement or the change in position there. And so when I look at that, I go, hey, the height of that triangle is 1.0 meters per second, and the base of that triangle is a half of a second, and then it's a triangle, so it's the formula of a triangle, so we have an extra half that's in there. And so now I have a half times a half, that's a quarter, times 1, so that is just 1/4. Cool, and I'm double checking myself to make sure I did that right. Yeah, that's right. And the seconds cancel out there, and I'm left with meters. So I got a 1/4 meter there. And then that means that here in this region, and let me outline that region there. You notice that I have the exact same triangle there. And so, hold on, this one's negative. All right, that's a negative velocity there. Hello. And then this one here is going to be positive, so it'd be the exact same math, but a positive 1/4 meter. And then let me do that in a different color. And then I go, hey, I have this little section in here. And this little section here, this little piggy went to market. 1.1 minus 1.0 is the time difference there. And then multiplied by the height there, which is 1.0, and then a half because we have a triangle there. So I have 0.1 times 1, that's 0.1, times a half, 0.05, 0.05 meters is that green one. And then you look down here and you go, hey, I have this exact same one there, but now it's negative, so this is negative 0.05 meters. And so then we look down here and we go, oh yeah, I can put in the units now. This down here is negative 1/4 meter. It goes 1/4 meter down, and then it goes 1/4 meter back up to there. And then it goes 0.05 meters high there. So I kind of made this one too high, so my scale doesn't really work out, but that's okay. We can tell that it's 0.05. I got the real numbers there. I could even plot that point. That is 1.1 comma 0.05 meters. And then it goes back down the 0.05 meters. And so it ends right where it began. Cool, that's it. We even made a quantitative graph, didn't fully need to, but it's good to be able to do more. Have a beautiful day. Take care. Bye.